In this video, we shall describe nonlinear systems, and we shall enumerate and describe the ways by which we can solve a system of nonlinear equations. Nonlinear systems. So a system of nonlinear equations in two unknowns. So we are restricting our attention here to systems of equations in two unknowns. It is a set of equations or a system of equations that contains at least one equation that cannot be written in the form ax plus by is equal to c. This is a linear equation. So what that means is it is a system of equation wherein one of the equations can be a degree 2 equation because this is a degree 1 equation. It can be a degree 2 equation or more than a degree 2 equation. Examples. Okay, so let us first recall, how does a linear system look like? Well, it is a system of linear equations. This one is a system of two linear equations in two unknowns. Since we just came from conic sections, and our conic sections, they are curves, they are defined by degree 2 equations. So in this nonlinear system, we will pay attention to a system that contains a degree 2 equation. So this one is an example of a nonlinear system. This equation is a degree 2 equation. This one is a linear equation. Solution to the system. What is the solution to the system? A solution to the system of nonlinear equation is a set of ordered pairs, x, y, that satisfies all equations in the system. So graphically, you can look at the ordered pairs as the coordinates of points. Those points are the solution to the system because the equations in that system contains those points. So for example, we have this nonlinear system, x squared plus y squared is equal to 4. The other one is x plus y is equal to 0. One set of solution to this system of equation. This one is a solution to this system because if we were to substitute this to x, this to y, okay, this to x and this to y, they will satisfy the equation. This one is equal to 4, and this one is equal to 0. And the same with this one. So this set is the solution set for this system of nonlinear equations. Or we can look at it graphically. Okay, just like what I said, you can look at the ordered pairs xy as the coordinates of points. And the reason why they became a solution to the system is because they are contained in the intersection of the curves that are defined by these two equations. This one is our equation for a circle. So by now, you should be familiar with equations of circle. This one is a circle with center at the origin and radius 2. So that one. And what else? Okay, I will go back. X plus y is equal to 0 is a line. This line is the curve that corresponds to x plus y is equal to 0. And so the reason why this solution set is a solution, graphically speaking, is because those 2 points are the points of intersection between the circle and the line. It is the points of intersection of the curves in your system. Okay, so let us lay down the methods by which we can solve nonlinear systems. These are the same methods we use to solve system of linear equations. We do it by substitution, by elimination. We can also do it by graphical method. If we were to do it by substitution and elimination, our goal, okay, so our goal here is to produce one equation in one unknown and then use this to solve for the other unknown. Okay, so I will lay down how this might be done. We do not have yet to pay attention to the details of this solution. I just want to show you what it means. The general layout of solving a system. So let's say, for example, I have this system of equations. One is a linear equation, one is a nonlinear equation. In particular, this is a circle. This one is a circle. Okay, let's do this by substitution. Okay, by the word itself, substitution, you know what's going to happen. So by substitution, if x plus y is equal to 0, that means x is equal to negative y. And I am now going to use this. I am now going to use this for x. Okay? So this is where the substitution will come in. Instead of writing it as x squared, I am now going to write it as the square of negative y. So that is where the substitution comes in. So this now, look at this. This now is an equation, okay? One equation in one unknown. One equation in one unknown. The unknown is y. And solving for y is plus or minus square root of 2. Okay, so y squared is equal to 4 over 2. So y is equal to plus or minus square root of 2. And we shall do back substitution. So we shall use this. So since y is equal to plus or minus square root of 2, x is also equal to plus or minus square root of 2. So that is the direction of our solution. From a system of two equations in two unknowns, we must produce one equation in one unknown. How about for elimination? That word itself is telling you what to do. You eliminate one term, okay? Or you eliminate one variable or one unknown. Okay, so in this example, how do we do that? We add the two equations. We add it vertically, column-wise. Okay, add similar terms. So x squared plus x squared is going to be 2x squared, y squared plus negative y squared is 0, 4 plus 1 is 5. So look at that. One variable is eliminated. And look at that. That is one equation in one unknown. So what is the value of x? X, we will get the square root. X is equal to plus or minus square root of 5 over 2. Now, some of your teachers will definitely require you to write the denominator in rational number. Okay, so this is square root of 5 over square root of 2. Square root of 2 is not a rational number. It is an irrational number. So how do you write it in equivalent form so that the denominator is a rational number? Okay, so this is one technique that you will do. Multiply it by 2 over 2. This becomes 4. The square root of 4 is 2. Okay, so that's it. Our denominator now is a rational number. And the numerator is simply square root of 10. Okay, I showed that to you because when I was about your age, I didn't know how to rationalize a denominator. So we know now the value for x. We know now the value of x. We have two values for x. So to get the value or values for y, you do back substitution. So when x is square root of 10 over 2, substitute it here, solve for y. So that is doing it by elimination. But we can also do it by graphical method. And what's going to happen in your class is your teacher will require you to produce a graphing paper. You will graph your circle. You will graph your hyperbola. Okay, by the way, let us go back to our system. I hope that you can recognize that this one is the equation for a circle in standard form. This one is an equation for a hyperbola, also in standard form. A squared is 1, b squared is 1. If we shall now solve that system graphically, what your teachers will require you to do is, okay, get a graphing paper. Sketch the graph of your circle. Sketch the graph of your hyperbola. Look for the intersections. Estimate the coordinates of the points of intersections, and those points will be your solution set.